Okay, so you guys ready? Here's
Yeah.
example one. X minus 1 over x plus 3 greater than or equal to 0. Give me a thumbs up or an oh no. Thumbs up means nonlinear. Oh no means linear. Ooh, interesting. Okay, this is nonlinear. Why? Variable in the denominator. Okay. So even though those are first, like the power is 1 on each of those x's, the fact that you still have a variable in the denominator means that this is nonlinear. Okay, example 2. 4x squared minus 3 less than, let's say 2. Linear, nonlinear. Thumbs up if it's nonlinear. Oh no if it is linear. Okay, guys, it's a 50-50 chance. You can just take a guess. I'm not going to judge you, I promise. No one else cares. That's how you got it. You got to be fearless when it comes to learning. Who cares? Okay. So I have a little bit of each, mostly thumbs up. That's because the thumbs up wins. It is nonlinear. Again, why? Even though this is not a fraction, the powers is higher than 1. Okay. So this right here, my square, tells me it is nonlinear. Okay. All right, ready? All right. How about this one? 7 minus 3x, all of that divided by 2, less than or equal to 2 minus 5x. Linear or nonlinear? Nonlinear means thumbs up. Linear means oh no. Oh. All right. Good job, guys. Okay, this is linear. Yes, this is linear. Because even though I have a fraction here, it's just the number, okay? That does not change anything. And all the powers are 1. So good job. All right, let's do one more. How about this? Square root of x minus 5x squared greater than, how about less than -8? Less than 8. Square root of x minus 5x squared less than 8. Linear or nonlinear? Remember, non is in a thumbs up. Oh no is linear. Okay, you guys are getting good at this. All right, so this is nonlinear. And we actually have 2 reasons. We have one is the root, okay, with a variable. Let's put it like this. Variable in the root. And then 2 is the fact that you have a power higher than 1. Okay, so there's 2 things going on there, but this first one is the most important one. Okay, it doesn't matter what's inside that root. The fact that you have any variable in there whatsoever makes it nonlinear. Okay, in fact, quadratic functions have a graph that is a curve like that. Okay, so it's not going to be a line for sure. Any questions on that? Okay. All right, so now we're going to pick up yesterday. And again, what I'll do on the first example is as I work it out, I'll outline the steps, but then I'm going to keep it very basic. Okay, so example 1, let's solve 1 greater than or equal to x to the third plus x minus 2 all over x to the third. Okay. 1 greater than or equal to x to the third plus x minus 2 over x to the third. Now, can I simplify out those x to the thirds? Do those cancel? The answer should be no, because it's not factored. Okay, we cannot just cross off those x to the thirds. If we could, our life would be really easy. So don't lose your simplifying skills. Okay, so I can't do that. So all right, so what do I want to do first? Anybody remember what the first step is from yesterday? What do we want to do first? Nobody remembers, or is everybody too shy to say? All right. What is it, Nigel?
All terms to one side.
Yeah, I want to get all terms to one side. Very good. So one, get all terms on one side of inequality. Okay, so even though it'd probably be easier to subtract the 1, it would be. We can do that. Let's do that. I want to show you something anyways. So say, so I'm going to subtract 1 from both sides. Okay. Actually, I'm going to do it like this. Okay, so let's go across. 1 minus 1 greater than or equal to this whole fraction minus 1. Okay, just because of the inequality, it seems weird to go underneath. I don't know. So 1 minus 1 is 0, greater than or equal to x to the third plus x minus 2 over x to the third minus 1. Now, do you notice how I'm muted? Oh, I don't know. I think people can hear me, Michael. Can you guys hear me?
Yeah.
Yeah, we can hear you.
Okay, all right, good. I think yeah, I think Michael, I think you're having some issues with your computer. Is that better though? Can you hear me better now? Or is it the same?
You sound the same.
I sound the same. Oh, this is a good microphone then. Okay. So Michael, if you need to leave and try to come back on, maybe try that or reconnect, check your sound with your computer. Oh, I'm gonna have to chat if he can't hear me, right? All right, let me put that in the chat for him. All right, give me 1 second. I'm just gonna pause the recording. Okay, so see how the zero's on the left side? That's not necessarily wrong, but it's a little more, we just like to read these left to right. So I'm gonna move this fraction over to the left side. And I want 0 over here, but I'm not trying to change anything. So do you see how the inequality is opening up to 0 like that? When I switch direction, it should still be opening to 0. This means the same thing. Okay, so this is the same statement. It's just reading it left to right instead of right to left. Is everybody comfortable with that? Or any questions? Okay. All right, so now step 2 is let's combine terms. Okay, I want one fraction. Since I do have a fraction, I would only want one fraction. It just makes all the calculation easier. You can do it without, but then you end up having to do a lot more fraction work later. I'm just trying to save you guys some agony, okay? So this is x cubed plus x minus 2 over x cubed. Now, how do I make a 1 have the same denominator? It's just going to look like that, right? X cubed over x cubed is 1.
Mhm.
So this is what we've done before, nothing new. Okay, good, Michael. I'm glad to hear that. And then when I put this together all over one fraction, ooh, nice things happen. Look at that, guys. Bye-bye x cubed. I like it. So x minus 2 over x to the third is less than or equal to 0. So you guys see these do cancel. Yay. Okay, so here's our question. Remember, once you get everything in the form we want, there's my question. And so what is this really asking for? Let's just review. Okay,
Looking for the 0 and the undefined.
we're going to need to do that next, but I just want to make sure we're clear. We're asking for which intervals of inputs will the outputs be what?
Negative.
Be negative or 0. Okay.
Mhm.
So, you know, that is something that you don't have to write down. Do you need to write this down? No. But you should make sure you understand this part right here. This is what we're really trying to do. Okay. It's the simplest way to ask this question. And this statement is the same as the very first one. Okay. It's the same as this one. It's just in a easier format to use. Okay. All right, so now I'm not sure who said that, but the real third step, the next thing is find your zeros and undefines. Okay, so here's my zeros. Thank you. Oh, and I'm gonna write this just as a function. F of x is x minus 2 over x cubed. Okay. Remind me to come back and talk about why you can't multiply by x cubed on both sides. I meant to do that yesterday, but I definitely want to talk about it today. All right, so here's my function. So zeros just means we set the whole function equal to 0. So this is x minus 2 over x to the third equal to 0. An equal sign does allow me to multiply both sides by x cubed. It's fair game. So I get x minus 2 is equal to 0, which means that x is 2. So this is my 0. All right, now my undefines. X cubed cannot equal 0. Okay, I can't have 0 in the denominator. Well, if I take the cube root of both sides, we just get that x can't equal 0. Okay, so there's the two things I have to put on my sign chart. So now we're going to construct our sign chart. And we're going to check regions. So this kind of all goes together. It doesn't need like two separate steps. So let's put stuff on our sign chart. Here's 0, which is my bad number. Can never equal 0. So I'm going to put an open circle. And then here's 2, which is a 0. Now, can I include this in my final answer? Let's look back at our question.
No,
Why not?
because we're looking for inputs that make outputs negative or 0, and 2
So,
is greater than 0.
Okay. All right, so Cornelius, let's check this out. If x equals 2, let's look and see what happens to my inequality. okay, I'm going to get 2 minus 2 over 2 cubed, which is 0 over 8. What is that? What number is that actually?
0.
0. Is this true? Is 0 less than or equal to 0?
Yes.
Yes. So 2 is what makes that function 0. And since I have this equal sign here, okay, it can equal 0. If that was just less than, like there was no equals, then no, we could not include it. So I'm going to go ahead and make that a dark dot so I know that I'm glad that makes more sense. Okay. So that is okay to include. All right, so we have 3 regions to check. All right, so my function is x minus 2 over x cubed. And here's one thing you can do. Some people like to organize it like this. Like they put little bars here. Kind of break up your regions. So I'll write the function up here. What's a number we can choose in region 1? What do you guys want to pick? -2. Okay, thank you, Madison. That works because it's less than 0. So I'm going to plug that in. So f of -2 is -2 minus 2 over -2 cubed. Now that's -4 over -8. Because remember, -2 times -2 times -2 is going to come out negative. And then we end up with a negative over negative, which is just, this is a positive 1/2. So I end up with a positive number. So that means all my outputs before 0 are going to be above the x-axis. Okay, greater than 0. Okay, between 0 and 2, there's really only one great choice, right? 1. 0, 1, 2. Perfect. So let's put in 1. F of 1 is going to be 1 minus 2 over 1 cubed, which is -1 over 1, which is -1. Okay, so I get a negative output here. All right, third region is x is equal to 3. So f of 3 is going to be 3 minus 2 over 3 cubed. And we see pretty quickly that this is going to be positive. All right, sweet. Okay. So now I know where my outputs lie. I know if they're positive or negative. Let's go back to our question. So last step is answer the question. And we wanted to know when this function is less than or equal to 0. So which interval are we going to pick here? This one, right? Okay, that's the one less than or equal to 0. So I'm going to go from 0 to 2. 2 can be included. 0 is not. Okay, questions? Any questions on this?
Yeah, I have a question.
Yeah.
At the beginning, why did you switch to inequality sign?
Why did I switch the inequality sign? Like right here. It's easier to read with 0 on the right. That's all. Okay. Because the way this reads here, if we look at it, it's 0 is greater than or equal to all that stuff. I mean, that's the same as saying that all that stuff is less than or equal to 0, right? Does that make sense? It's just easier. Usually your inequality symbols, you read left to right. So this is less than. I want to know when it's less than 0 or greater than 0. Does that make sense?
Couldn't we just subtract the whole fraction to the left side and it will still stay the same, the inequality sign?
Yes, you could. You could. It's just would have reversed some signs. If we had done that, let me show you how that would have been different. I'll do it over here. If I did 1 minus, it would have been 1 minus x cubed plus x minus 2 over x cubed, like this, okay? Okay. The only danger here is that when you subtract, you have to be careful. You're subtracting this whole top part. Okay. So this would become, oh, why isn't it change? Wait a minute. Oh. Okay. This is wrong right here. The symbol was this. Okay. Sorry. I was like, wait a minute, we can't get the same thing. That wouldn't make sense. All right, so do you see how the inequality is greater than or equal to? If I subtract that fraction to the other side, it's still greater than or equal to, okay? So we end up getting x cubed minus x plus 2 all over x cubed greater than or equal. And I have negative x plus 2 over x cubed is greater than or equal to 0. This is the same as x minus 2 over x cubed less than or equal to 0. Why? How are these the same? That's my
Because
question.
there's a negative in front.
Yeah, because this negative. So if you did it the other way, you just would have been answering a different question and you would still get the same answer because these are technically the same things. This is negative x minus 2 over x cubed greater than or equal to 0. And if I multiply both sides by a negative 1, that would get rid of it, but I would also have to flip here. So these are the same. So it doesn't matter. You just have to make sure you respect all the rules when you're going across an inequality. And if you didn't understand what I just said, that's okay. As long as you understand what we did up here, that's fine. Okay. But for like, who was asking me that?
I was asking that.
Muhammad. Yeah. You just have to be careful with the negatives. All right. I want to talk about why can't we multiply across the inequality by a variable? And it kind of ties into what I just talked about here. It has to do with the rule that when you multiply across an inequality, if it's negative, you have to flip it, right? So recall multiplying or dividing across the inequality reverses it. Okay. So let's look at an example like this. Let's just look at 3 minus x over x greater than 0. Okay. So wouldn't it just be easier if we just could multiply by x, right? If we could, then I would just like in the equation, the question is, why is this illegal?
Because like you can't multiply them because I guess since it's a minus sign at the top.
Okay, that's a good point. This part doesn't matter, so let's just make it plus. But you're honing in on the negative sign.
It's not in factored form, so you can't. I don't know.
Okay, thank you for trying. What if I multiply by a variable? What does a variable represent?
An unknown number.
An unknown number. Okay. Variables represent, and in particular, they represent any number. Meaning it could be, oh, now my pen's going to go out for a minute. It could be positive, it could be negative. We don't know. Okay. So when you multiply by an unknown, you don't know if it's negative. So you don't know if you need to flip that. That's why you can't do it. Is that clear? Come on. That wants to give me a hard time.
Okay, I'm guessing everybody just got that. Oh, okay.
Oh my God, really?
Ow, my ears.
My phone said, bzz. I heard it. I said, that mean everybody else just got it too.
Sorry guys. All right, anyway, so the variables represent any number. We don't know if x is a negative number. Therefore, we don't know the rules. Okay, so we don't know if x is a negative number, so we could be breaking the rule. Okay, where if you multiply or divide by a negative, you have to reverse it. So I want to put a big no here. Do not multiply, divide by a variable across the inequality. Okay. If you do that, if you try to solve this way, okay, you automatically get a 0 on that problem. You get no points. It's that big of a deal. Any questions? All right, let's try this one. Example 2. Let's do one like this. X cubed is greater than negative 3x squared. Now, what do we want to do first?
Get everything on one side, so you add the 3x squared to the other side.
Beautiful, beautiful. You do not multiply or you do not divide by x squared. If you're tempted to do that, you cannot do that. So let's add 3x squared. So this is going to be x cubed plus 3x squared. And on this side, I have negative 3x squared plus 3x squared. So you have x cubed plus 3x squared greater than 0. Okay. Now, I'm going to, I don't have to combine, like I can't add or I can't simplify this anymore. There's no fraction or anything like that. So let's just go for our zeros and undefines. So my zeros, oh, by the way, this is my question. I'm going to just box it in. Okay. So I'm going to write this as a function. and then set this equal to 0. And I really want to encourage you guys, make sure you do all the steps. If you try to shortcut it, the best thing you can do for yourself is set up like something that feels like a routine. Okay, first, second, third, do all the steps, show all the work, do not shortcut this, because that's when you will make mistakes. All right, so let's see, how do we solve this? What do we do here? I heard you loud and clear. You said factor out the x squared.
I didn't say it, but my brain was like, do we factor? I was like, I think
Yeah.
so. And then you said it. And
I
was
wrote
like,
it
oh, okay.
down.
Okay, good. That's okay. I know it's awkward because if everybody talks at one time, but so we're going to factor out that x squared, and then we have something multiply that equals 0. So we use our zero factor 0 property. So this is equal to 0, and x plus 3 is equal to 0. And if you square root both sides, you get x is 0, and this is x is -3. So my two zeros are these two. Now, what about undefines? Or bad numbers? There are none. Okay, this is just a polynomial. Polynomials don't have any undefines. So on my sign chart, so next step is sign chart. Check regions, all the same thing. So I have 0. Oops, -3 comes first. I have -3 and 0. And I'm just going to check right now, do I include these in my final answer? So let's look back at the question. What do you guys think? Are these zeros getting included?
No.
No, because there's no equal sign. So again, just to check, I just want to do a little check here. Understand this. If I plug in, let's do -3 because it's more interesting. If I do this, I end up getting -27 plus 3 times 9, which is -27 plus 27, which is 0, and is 0 greater than 0? False.
No.
Okay, so zeros are not included. Okay, so we're gonna put, I'm gonna put open circles here, so I try not to forget, okay? And here's region 1, region 2, region 3. All right, I'm gonna let you guys do this real quick. Remember your function is x cubed. You know what? I would suggest using the factored form. It's easier. But you guys pick numbers. Go ahead. I'll let you work on this for a couple minutes on your own. Mhm. Good. So you should have gotten, Madison put it in the chat, negative, positive, positive. So my regions are negative, positive, region 2 is positive, and region 3 is positive. So again, that means your outputs before from infinity to negative 3 are below the x-axis. From negative 3 to 0, your graph is above the x-axis, and from 0 to infinity, it's above the x-axis. All right, so let's see. I want to know when it's greater than. Okay, awesome. So that's my positive regions. So we're going to start with negative 3 and go to 0. Now, here's my question. Is it going to be this? Or should it just be negative 3 to infinity? Which one is this? Which one is it? Yeah, the first one. Why? Why does it have to be this first one? Because we can't include 0, right? Okay, 0 is a 0 of the function in this case. And we already said it cannot be included. So you have to use your union. You have to union those two sets together to not include 0. So it's not this one. It's definitely this one. Okay, 0 can't be included. 0 is not included. Any questions on that? All right. Okay, we are cruising along here. Here we go. Example 3. 1 over x plus 3 is greater than or equal to 1 over x minus 4. All right, so why don't you guys, I'm going to give you a minute to try this on your own. Okay? Give you like a 2-minute head start, and then I'll start going through the steps and you can check if you're getting it right. But try it yourself. Okay, I'm going to start. I would have subtracted 1 over x minus 4. And then we need a CD. Mhm. Mm. All right, you guys still with me? When you subtract 1 over x minus 4 to the left, you have to get a common denominator, right? Which is x plus 3 and x minus 4. And then when you subtract those, the x's are going to cancel out, and all you get on top is a -7. So you should get -7 over x plus 3 times x minus 4 greater than or equal to 0. And my advice is, here's my advice. And in the realm of mathematics, I would say my advice is pretty good. Now, if you ask me for financial advice, probably that's not good. But in mathematics, I can't tell you anything about the stock market, but I can tell you to leave these factored. Leave factored. Okay. All right. So after you have that, now let's do our zeros. Step 2 is zeros and undefines. Are you guys there yet, or do you need another minute? Let me know. Does that mean you're
There.
ready? You guys are ready?
Yeah.
Okay. All right. So if I write this again, I like to look at it as a function because I cannot operate on the inequality. Okay. Don't touch that inequality. I'm going to come over here. And I know it just seems like a technicality, but it's a mentality. It's a mentality. Look at that as a function. So when I solve this as a function for zeros, I'm going to set it equal to 0. That's what we do. Okay, and then we're going to multiply both sides by the denominator, just like we would, because it's just an equation. Oh, this is -4. What am I doing? And I'm going to do 0 times x plus 3 times x minus 4, which is just 0, okay? But these clear, and I get -7 equal to 0. Uh-oh, all my variables went away. What does this mean? What do you guys think that this might mean? Because I know it's not true. No solution? It definitely means no solution. So let's write that first. There's no solution to this equation. But what this means in terms of my sign chart is that there's no zeros. Okay, i.e., this function never crosses the x-axis. And, you know, that can happen. It doesn't have to. Okay. But I am going to get some undefines here. So I know that x plus 3, the denominator, we have to say, set that equal to 0 and find what numbers won't work. So x plus 3 can't equal 0. X minus 4 can't equal 0. So x cannot equal -3 and x cannot equal 4. So those are the things that are going on my sign chart. I don't have any zeros to put on there, but I have 2 bad numbers. Okay. So I'm going to put my sign chart here. And I just like to go down. So let's go down here, sign chart. All right, -3 and 4. And since they're both undefines, I'm going to put open circles. And we have 3 regions to check. Now, this is where it's helpful to leave this factored, especially. Well, it helped because I didn't have to refactor it to find the undefines. So I'm going to pick x is -4. So let's do -7 over -4 plus 3 times -4 minus 4. Now here's a little bit of a cheat. Okay. I don't mind if you calculate the numbers, but sometimes you don't have to. So this -7 is going to stay negative on top. -4 plus 3 is a negative number, and -4 minus 4 is a negative number. So this is going to end up being negative over positive. So that means my final number, whatever it is negative. So you can sometimes do this. Just look at the signs. How are the signs going to play out? Because you don't really need the output. You just need to know if it's negative or positive. If that doesn't work for you, then just, calculate it out. No big deal. So this is -7 over, I'm going to have 0 plus 3 over 0 minus 4. Now see, this is really easy. -7 over -12, which is negative over negative, which is positive. Okay. And then I have x is equal to 5. That's the other one I'm going to pick. So -7 over 5 plus 3, 5 minus 4. And I see this is negative over positive times positive, which is negative. So you should have got negative, positive, negative. All right, so let's go back to look at what the question asked for. It wants to know when it's greater than or equal to 0. So that means positive or 0, but we know we don't have any zeros. So the only region is from 3 to 4. This is the only part that works. So my answer is from 3 to 4 and not including 3 or 4 because they're undefines. Any questions? All right, you guys, have a good day. I will see you tomorrow. We will do review for the test.